How's it going, you guys? In this video, I'm going to be talking about bearings. Oh, not those kind of bearings. I want these kind of bearings. Yeah. So, and notice in like this one, this is a compass. Notice it has north, east, south, west, and it also has a bunch of angles on it. These angles are what we are going to use. They're called directional angles. Directional bearings, like if we wanted north 15 degrees east, I could go to right here, and then I could walk that direction or whatever. So first, I want to get you guys started by just getting comfortable with drawing bearings how they are. Notice on those pictures, sorry, I can't go back to them. Oh no! Let's pull it back up. What did I look up? Compass? Compass. Yes. Image. Yes. Yes. 0 degrees is straight up. Due north is considered to be 0 degrees, and notice they go around clockwise. So 90 degrees is right there, 180 degrees is right there, 270 degrees is right there, and then a full circle would be 360, but it just brings us back to 0 degrees. So when we're drawing these things, so like first one here is 120 degrees. That's a little bit more than 90. It's actually 30 more than 90. So 120 degrees would be somewhere right there. So that is the direction of 120 degrees. 42 degrees would be in the first quadrant, where it is 42 degrees right there. 230 degrees would be less than 270. So we are somewhere right here with 230 degrees, since it's 50 more than 180. 290 degrees is bigger than 270. Says we have like 0, 90, 180, 270. So it's a little bit bigger than that. It's 20 degrees bigger than that. So this bearing right here would be 290 degrees. Bearings are used in navigation, obviously, since you saw the compass. Now, if we have directional bearings, it's telling us we are going from north 21 degrees to the east. This always goes from the pole. So from north, remember north, east, southwest, never eat soggy wheat. I said that today, but it's apparently a faux pas. It's supposed to be never eat soggy waffles. I'm so sorry. So this is 21 degrees right there. North 87 degrees west means that we are going from north 87 degrees, so that is 87 degrees right there, to the west. South 52 degrees west would be from the south 52 degrees to the west, so that is 52 degrees right there. And south 45 degrees east would be from south 45 degrees to the east, so that our 45-degree angle is right there. So now I'm going to walk you guys through a situation. It's a beautiful situation because it's talking about monkeys and banana splits and all sorts of wonderful things. So now it says an airplane leaves Banana City. I'm going to call this BC. With a bearing of 220 degrees towards Split Town. So if I'm going 220 degrees, that means it's going to be something-ish like this. So I know I'm going to be going from north, I'm going to be going to the south. So if I draw that, I'm going to draw Banana City somewhere right here and put it at Banana City. Now notice, I drew a compass northeast, southwest at the point so that it is easier to draw my bearing. Because I know 220 degrees is something like that. He went that direction for 670 miles towards towards Split Town. So Split Town, ST. That's what I will call that. All right. And then it says once the plane arrives at Split Town, so now we are here. The next trip is on a bearing of 340 degrees to Banana King's Tower. At a distance of 1,000 miles. So it'll be a bigger distance than this. And from here, so notice I'm drawing another bearing so that it's easier to figure out where my bearing is. So from here, I'm going 340 degrees. So 340 degrees is almost 360 for 1,000 miles. So now I'm going up there for 1,000 miles at a bearing of 340 degrees. Once at the tower, the plane returns to Banana City at the end of the day. So from here, he's going back to Banana City. So we have completed our round trip. So now we can start to determine some things. You're going to have to remember for me some of geometry. So I knew first I went 220 degrees. So that was 220 right there. So if that's 220, then that means this angle right here should be 50, and this angle is 40. So if this angle is 40, by alternate interior angles, if I draw this up and extend it a little bit, this angle right here on this side is 40 degrees as well. So don't forget alternate interior angles. If I have two parallel lines with a transversal, two parallel lines with a transversal, alternate interior angles, so these two right here would be congruent to each other. So since this is 40, that is 40, and I knew I went 340 degrees around, so that must be 20 degrees right there. So that means this whole angle is 60 degrees altogether. So now the first thing it's looking for, determine the distance from the tower to Banana City. So I want to find that distance right there, and I can do that using what we just learned previously with law of cosine. So I have d squared equals 1,000 squared plus 670 squared minus 2 times 1,000 times 670 cosine of that angle across, which is 60 degrees. Once we do this calculation, we will figure out that we have 882.55 miles, 882.55 miles. All right, so there's our distance there, 882.55. So now it says determine the bearing the plane must take in order to return to Banana City from the tower. So I am at the tower and I want to go to Banana City. So from the tower, the bearing to Banana City is right there from north around to where my vector is. So now I knew that this angle down here was 20, so this angle inside there is also 20. Well, it'd be nice if we knew that angle right there, because this angle plus the anterior angle of the triangle plus my bearing would be 180 degrees. I know that one, so if I figure out this one, then I can take both of these away from 180 and figure out what my bearing is. Well, don't forget about law of sines, we can use that. So sine of that angle I'm looking for, I'll call it theta, theta over 670 equals sine of 60 over the side I just found, so 882.55. Type that in your calculator and your angle will come out 41.11 degrees. So now, since I know that that is 41.11, that is 20. 20 plus 41.11 plus my bearing that I must take from the tower back to Banana City is 180 degrees. So since I know that, my bearing is 180 minus that 41.11 minus 20, and that will give you a directional bearing of 118.89 degrees. All right, hopefully this video was helpful. Please, please, please come ask us questions. We're here for you guys. We love you guys. We want to be able to help you with anything and everything. So speak up. We can't help you if you don't. All right, I'll see y'all soon.